Good afternoon to all. Thanks for giving opportunity to the ma'am. Thanks to Bhuvan sir also. He already touched the GIS important, GIS and GPS important. He showed some maps. Because we need to. Yeah. That's okay. Yeah. Just nature of GIS and its application in archaeology. Here I am touching only the documentation purpose only, not in the archaeology excavation I didn't touch, only documentation purpose, this GIS and GIS. That means GIS application in archaeology. So the main objective to document the built heritage sites and all antiquities. First, documentation of the built heritage sites and all antiquities. Next, document the geospatial. First, document the object, then where is located. That also, document the geospatial location. In the sheet, their latitude, location, latitude, longitude they mention. So, yeah. So, we are okay. Documenting geospatial location of the built heritage sites and antiquities. Finally, to visualize the documents in various formats. So, 3 assignment using this tool. 3 assignment. First, the documentation of the object, then geospatial location, where finally visualize the format. For that, instead of the GIS, I am telling geospatial technology. Now the geospatial technology is a package, remote sensing and geographical information system, GIS, then global navigation satellite system, that means GPS. Then the finally internet mapping technology also. The four tools together, it's called GIS spatial technology. It's not just going. Already I told for the documentation of the object, then document the location, then finally what we documented, that to visualize purpose. This 3 purpose we are using the geospatial technology tool. Next one. So in this tool, we have the 4 tools we have in the geospatial tool: remote sensing, geographical information system, and global navigation satellite system, GPS, then internet mapping technology. Okay, next. So what is the remote sensing? Just without touching, if you're just viewing, that also is the remote sensing technology. Taking the photo, that is there, from the drone, remote sensing technology, from the satellite, remote sensing. So we are taking the, without touching any, taking all the object, photo, all the things, this is called the remote sensing technology. So here, how we are using this one? First, satellite images. If you want the big area, we can use the high resolution satellite images. Then photography, normal photography. This is the that also comes under the one. Nowadays, the photography all comes with geotag, latitude, longitude, automatically. If you take in your mobile phone, if it location is enabled, it will come with latitude, longitude. Immediately, it is possible in the GIS software to upload that image with the place, particular place. So geotagged image. So the photography is the taking picture, remote sensing one. Then your location also is there. Then UAV capability in archaeology. I'm telling this, nowadays is a very good tool for the archaeology people. One is normal drone, taking the ortho photo using the drone. That is also same time, if you use the differential GPS survey and control point using this photo, well, geo-referenced air photo for your sites, for your any monuments, anyone. Then this data is possible to build the 3D models also. Then the next one, LIDAR survey. LIDAR also. LIDAR is possible aerial, terrestrial, and handheld also. So if you take the aerial, already sir mentioned that entire, if you want your entire study area, your area digital elevation model using this LIDAR, it's possible. Because previously plane table survey told, then the next total station told, that's also time consuming. Now we are using the LIDAR survey within a day. say they will give the contour mapping with centimeter level they will provide for the using the LiDAR data. It's an easy to one. Okay. Then the terrestrial LiDAR. If you want documentation purpose, if any heritage sites, if you want this area, this building, exactly the 3D model is with all the measurements, with all the geometries one, it's possible to the terrestrial LiDAR, using the terrestrial. Same this terrestrial LiDAR output also for the any monuments to cracks, wherever the cracks, that also measuring all is possible to using this LiDAR data. Then handheld, because first I told aerial for the entire, from the aerial to map the surface. Again the side object using the terrestrial. Then if you are small antiquities, small things, you can use the handheld scanner. It is possible to create the 3D models for this one. Okay, so this all comes under the remote sensing technology. So this is for the documentation of that object that that is building or small antiquities or our survey site all. Okay, next please. Okay, here I will give small examples from the satellite 2 up to LiDAR data. I will give the examples. This is just a Mondo area satellite image. I told high resolution satellite image. Resolution means in the ground 50 centimeter object is possible to identify this one. So on the ground, if it the mosaic data, mosaic in the ground mosaic, just 50 centimeter if it the cell size, you can possible to identify this 50 centimeter. Nowadays it's up to 30 centimeter. Next image. Nowadays in the Google Earth World View 4, 35 centimeters resolution, the data are available. Okay. Next. Yeah, this is a high resolution, our Taj Mahal data in this one. Next one. Yeah, this is a World View 3 data. I told 35 centimeters. This is just Paris Eiffel Tower area. So it's like a air photo only. If you want your area is more, then you can go with satellite data. If your area is very less, you can go with drone. That is the cheaper for you. The next one. Yeah. This is a drone photo. This is one of the Tamil Nadu State Archaeology site monument. This is from the drone, documentation drone. Next one. Yeah, this is also ASI monument in Tamil Nadu only. This is all are drone photos taken from drone. Is one. Next. Yeah, I told the terrestrial LiDAR. So this is that one is. Terrestrial. Previously aerial photo I showed. This is a terrestrial LiDAR. Next one. From the this was handheld LiDAR scanner. So the terrestrial and handheld. This is useful for the antiquities. All this one is possible to handle. Next one. Yeah, this is one of the output for the terrestrial LiDAR's output. On ASM, terrestrial LiDAR output is one. It's possible to create the 3D after using virtual VR also is possible. If you go inside all the things, wherever you want to go, all is possible. We will do this one. Next. Yeah, this is also 3D model because we taken the LiDAR data. Based on the LiDAR, we build the 3D model in this one. Okay, next. Now is the thanks to 3D printing. Because if we were once antiquities, if we scanned by the 3D one, it's possible to duplicate the 3D models also. The same texture also possible, different sizes. This is the same temple with 3D printout also. Next one. Yeah, coming to this handheld scanner, I told antiquities that we used for the rock art portion. Rock art part we used for this one. Because this is exactly 3D view or 3D view is giving. Afterwards, it's possible to the visual this museum. Because always the rock art is above the hill, must be very distance from the access. So if you want to virtual museum, create the virtual museum, you take all this data. We can build this virtual museum is possible using this LiDAR data. As it is same as one. Next. So 3D models, some antiquities. I'm telling you. Using this one, it's possible to create the 3D models with all the measurements same. You can possible to identify. Next one. So This is all using the remote sensing. So in the geospatial tool, I told the remote sensing, GIS, GPS and web mapping. In this one, remote sensing, documentation the object is the first one. Okay. So next one Next, I will touch the GPS. Already, Sir touched the GPS useful because before we depend only the US only, GPS only. Now we have the own system, Indian Regional Navigation Satellite System, IRNSSS. So most our very easy to get the latitude, longitude nowadays. Previously, we depend only the topo sheet only from degree minutes. Using the grid. Even in my career starting time also, I used the topo sheet only, background on tracing paper. That tracing paper I divided like that we get. Otherwise, another possible if you want, if you any railway station, the station they mention latitude, longitude and elevation also. This is the data. Nowadays it's not a big deal. In the hand, you have the GPS all is there, latitude, longitude. So you can use it. That is possible. If you getting from already Sir sold, if you getting that if in a small villages you are taking from the topo sheet, then you can convert now the GIS software. There is a possible to Everest datum to WGS 84 datum. So whatever datum, whatever projection, you can just check before the documentation. Some maps, some UTM, some projection, some is polygonic projection. Like that is they mention what projection they used. Using that one, you can convert. Now is WGS 84 and then UTM projection. That is universally recognized one. For mostly in the West India, it will come for UTM 43. East Indian mostly come with UTM 44. Okay.
There are map projection systems. So the maps that you are getting not always uniform. Preparation of maps is difficult. So I'm sorry to intervene because he is dealing with at a certain level. May not be many of you are not aware of the map projection systems. So that's what he is saying. I'm just trying to explain because down below may not be you are aware of it. There are different map projection systems and each map projection system will create different maps of the same area. Because there are conical projection systems, there are cylindrical projection systems, and there are several kinds of such projection systems. So, what he is now talking about, that is a particular type of projection system. Because Earth is round. If it was flat, the single type of projection system would have been sufficient. But because it is round, it is spherical, and not even spherical, exact spherical, it is an ellipsoid sort of thing. So there you have different projection systems so that exactly the land area can be covered in the map. It is not very easy. There are errors in every map projection system. So, yes, best fit.
That's why up to now I didn't touch this one. Today, Sars touched the.
He's coming from that side. I am going down below so that many of you who are not familiar with it, so just to give an idea what it is.
Okay. Sorry. Okay, thank you. So today, Sir touched that one, that's why I did. Okay. Yeah, then this is GPS. Nowadays, Nadia, it's a big deal. Yeah, it's a different GPS also. Depends upon your accuracy. If you want centimeter, millimeter accuracy, you can differential GPS, you can use it. Otherwise, the normal GPS is possible. This depends upon the cost wise also. If you use a differential GPS, up to 50 lakhs is there. Then up to normal GPS, up to 10,000 it's available. Now mobile phone it's available. Your purpose is mobile phone GPS is well and good. You can use it. That is enough for this one. Okay. Then another thing is too important because I did. If you take the old all is one, they mention only degree and minutes only. your inform all is there degree minutes only. If it 1 degree nearly the 110 kilometers, then if you come the 1 minute almost 1.5 kilometer, then seconds. If you mention only degree minutes on that region, not a particular point, if you go with seconds, if you 1 seconds, almost it will come 25 meters. 80 feet is 25 meters, 1 minute, 1 seconds. So the previously we used, because not possible to give the data up to minutes data. Now we have the 6-digit minutes is possible. And that time only degree minutes only. So you can check that region, because degree minutes if they used that entire area is on almost. Okay. So yeah, next. Then coming to the GIS. So first we saw remote sensing technology, then GPS. Okay. Then the third one, GIS. So here GIS already is a computerized software only, data storage, data creation, then storage, then analyze. Same our data specialist, same concept only here. First data creation, data collection. First data collection and creation, digitizing. Then data cleaning. Then the analyze also. Here the analyze also is one visualization. It depends upon your study. Okay, it's that. So next one. Yeah, this is input, pre-processing, analyze, output. This is the main one. So if you want the data, you can first collect the data, all the latitude, longitude data, you need to collect. Then if any correction, you correct it. Then the analyze, because sir did the analyze. So all he visualized, then he did this is a trade route, like that, analyze. If you once plotted spatially view, then only you got the analyze possible. The final one, output. They create the thematic maps, statistics, all is that. This is the main one. Next. Then basic GIS tool is three. Point information. All your data is, most of the location data is point information. Then line information. If it any road network, river, you are telling us line information. Point, just that location only is telling us point information. Then any road network, all is called line information. Then the polygon. If you show the entire your monuments, whole area, then polygon. If you show the lake, if it district boundary or state boundary, it's all are polygon. So this 3 data only, vector data, 3 data only. All your data, point, line, polygons. Then raster. Raster means all the like air photo, satellite images. This is raster images. This is grid-wise images. Next. Some free software, QGIS. QGIS is freely available. It's a good software. You can use this one. Then DivaGIS, Saga, ArcGIS. Our Google Earth is enough. Google Earth, I think most of all people know the Google Earth. Google Earth, and now is Google Earth Pro also is easy. Immediately if you want your latitude, longitude of the place or simple map, is possible to Google Earth. Sir showed many maps using the Google Earth only. Without knowing any GIS, is an easy tool. You can use it the Google Earth. Okay, next one. Then the data sources. Already told, if it just name only, no. If nowadays is possible, you can check in the Google Earth. That place is possible from the getting the latitude, longitude. Otherwise, if it's a very small hamlet, that one you can use it topo sheet. Nowadays, all the topo sheets are freely available from Survey of India. You can download it from Survey of India. Just registered, you can download. All the Survey of India topo sheets are available. Then GPS data. So your data only. We collected the latitude, longitude from the GPS. That also one source. Then geographical locations from various data means already published data. Already published, they will mention in this lat long, this object is there, this build heritage is there. You are seeing the different objects. That also you can one of the input. Then finally, yeah, free data means I am telling the just district boundary. If you want to show the district boundary, road network, all the things are nowadays available different website. Before we need to create all the things. Nowadays district boundary up to village boundary from the Survey of India website you can download. download from the GIS format. From Survey of India, you can download it. We want geology, geomorphology, all the map from the GSI website. GSI, Bukosh, website name is Bukosh. So you can download the data, all the things. Apart from Bhuvan, Diva GIS, all the data are available. So you can freely download your state administrative boundary from the Survey of India website. Okay, next one. So then coming to value of the maps. That he given the study area for the central portion. Without mapping, he is telling just 4 state. Because he showed background is with physical map, his study area he showed. Then only you got immediately that side is hilly land. Then the alluvial plain region, then hillock region, all is there. So the visualization is important. If you given the table for 10 or 5 or 10 pages, but if you give the one map visually, it's a very good one, visual one. Okay, next. Yeah, conveys the information visually attractive manner. And here is we can give the different colors, different. I will show the different map. I will show you. Then you will get the idea about the visualization. Okay, next. Yeah, here the major data structure here. Vector already sold. Point, polygon, line data. Then another raster data. Then DBMS data. Your databases, all your databases, point information data. Because background, if it's the latitude, longitude. It's a building heritage, what type of the monuments, what type of the building, all the information is there. Then we can put all other layers also. That is the good. If you want the road layer, if you want river layer, any other geology, geomorphology, whatever layer overlay is possible in this system. So easily interpretation, it's easy if you're using this system. Next one. Okay, so the uses of this one GIS, construction of spatial database. So that one is table information database only. If we created using the latitude, longitude, spatial database, all the database with the spatial information also you have. Then easily to query attribution in this district, how many monuments, if you want, immediately is possible to query this one. This type of the monuments where it is falling, that also is easily query is possible. Then geostatistical methods, spatial analysis, cluster analysis, predictive modeling. After once the data is ready, you can use it different way. I will give some gap analysis, all other I will just give the examples. Next. Yeah. Up to now, we saw just basic things. All the one is remote sensing, then GPS, then GIS. Then we are now documenting I will give some examples. For here, rock art. Last 2 months, 3 months before we visited and we taken the rock art data taken. So first this is the remote sensing, just collect the data using the collector, just a photo or LIDAR, this one like handheld scanner we used. So the data is we collected. One next. Another places. This is just first data collection. Next. Then type, place name, latitude, longitude. Because for we collect just I given the 2 examples for the photos. Then afterwards collection of LIDAR handheld scanners 1. Then type of the rock shelters and place name, latitude, longitude, and altitude also. So the latitude, longitude is important. This is database. If you all the build heritage site, then it will come like that only. Then next, using this data, I am mapping. Next. So in the topo sheet. So this is topo sheet 1:50,000 topo sheet. I downloaded from the Survey of India website. I downloaded, geo-registered based on the latitude, longitude. Just PDF format only is available. So you can convert it to image. Then you can register it using the GIS software. Then I plotted that shelters in the topo sheet. This is the database. Next. The same one, I put it in the Google Earth background. So for the analyze purpose is useful for you. Next this one. I put it in the elevation model. Previously, we only depend upon for the contour only from the topo sheets only. That is only topo sheet 20-meter contour. That is what. Nowadays, there is a lot of digital elevation models are available. If you visit the one website, there is a Cartosat elevation model. It's available 30-meter resolution. That means in ground 30-meter cell size. But the elevation wise, up to 1 meter it's possible to create the contour. This is useful for whole, that is regional areas one. If you have the one lidar survey or aerial photographic DEM created the digital elevation model, then up to centimeter level possible to create the contour. Okay, if you use this one. So here I used the SRTM model. I create the elevation model and contour also. This is abroad. Okay, next one. Using the same elevation model only, I am creating the drainage pattern also. So once if elevation ups and downs, all where this possible flow is possible. So we can, based on that one, I identified water also. So now you can see interpretation purpose. All the rock art sites are in the valleys only. Just not the central river is going valley in this side and right side and left side is there in the bank. This one, just for the interpretation purpose. Next one. So next, I am telling to the publication purpose, because we wanted to publish for the world, entire world. So in India, in the Tamil Nadu, where is in the Tamil Nadu? In the Tamil Nadu, which where in that particular Tirupur district. So the key maps, documentation. So just first I started with my object. Then in that object I plotted in the special information. Then that one where is in the falling in the India, I am showing the next one. Then we need to geology, geomorphology also, where you have downloaded from the, I already told, GSI site, just background of the geology, geomorphology. This too is very important for the rock art sites. This is for the interpretation purpose. Okay, next. So this is one type of the map. Then I will give some example, physical map. So using the elevation model only, we prepare the physical map, because we have one project, because we are creating a Tamil Nadu atlas, archaeological and historical atlas. In that atlas, we are preparing different layers. I am giving the example from that only, because it's a hard copy atlas we are planning, A3 size planning. So the physical map, we are prepared physiographic map of the Tamil Nadu. This is information is useful for the archaeologist as well. Next one. Then Buddhist sites. Just Buddhist sites already it's available in this one. Just mapping purpose. Because if it only latitude longitude I have, we are plotting that one. It's the Buddhist sites. Next one. Different maps I am showing this one. Roman coins. Actually, the screen not clear. Roman coins map. Okay, in the sites in the Tamil Nadu. Next one. So I put it in the river map. If you want road map, it's a overlay. This is a specialty is the GIS. If you want road map, how to access that place, we can easily put the road map, road layer in this top. Road map is public. If a district map or a village map, whatever want, you can overlay is possible here. Okay. Here I put it only the river map only is there, and major town also. Otherwise, if it's too clumsy, depends upon your size. Okay. Next one. Here is, if you want your database ready, if you want a state-wise or if you want your basin-wise, all is possible. If I am working for the Vaigai River Basin only, because just Vaigai River Basin, what type of the megalithic monuments, different monuments, database only, circle all this, only the particular valley. Next one. Site dealing black and red ware India. So entire India. That sites are where for this one is already sir told the interpretation is easy to once if it spatially is one, the most of the sites falling in the coastal region only. This one. So the interpretation is useful for this one. Next one. Citing Rowlatt River. This one only the mostly. Sorry, citing Rowlatt River mostly in the coastal area, coastal region. Because sorry, not previous one. This one. Full and full data. A lot of many data in the citing Rowlatt River in the India coastal sites. Next one. There another one. Yes, sure, totally. Small is our own publication purpose. He's the author in Kannada. He asked to me to the Saiva. Which one is nothing? Okay. Just inscription about the Alvas, that is map. Alvas and Saiva is one, Mats is one. Okay, next one. And then this is the Neolithic sites. This is also for publication purpose we used to showing just visualization how the maps are helpful. Next one, prehistoric sites. Prehistoric sites map in this one. So you can, background is physical elevation model, state you can give, then your sites, all is the visual interpretation. Okay, next one. Then Tamil siding outside India also. If you want to give this map also, so all the data only, data plus latitude, longitude, if you have, you can play with your own maps, different maps. Okay, next stage. So here, if you want to show your own, your excavation site, all together one A3, A0 poster. So description, India, Tamil Nadu, where the Vaigai Valley, then your particular Keeladi sites, all is possible to this one. Within a map, you can all the antiquities, important antiquities also. Like that, it's possible to show within a one A0, you can inform all the information. So here contour map is there, geology map is there, entire basin is there, particular excavation is there. So all the information, if you want, this is a visual, giving this your data to the public. Okay, next one. So up to now we saw different maps we saw. Now is NMMA collecting all the map. They want to put the public, so internet mapping technology. Because this is a huge one. It's not possible to printing format is not possible. So if you the internet mapping, web mapping portal, then it's possible to up to zoom level, different zoom level it's possible. Because nearly 58 lakhs of antiquity, all their mapping. So this is internet mapping now is very much helpful in this one. That here we did one South Indian archaeological and historical atlas. I will just give the example for that one. Okay, next one. Yeah, this is a case study. We worked for the Tamil Nadu and Kerala, small portion for Hyderabad area and small portion in Mangalore area. So for that we did from the Stone Age to up to 16th century. We mapped here all the data. Next one. So here is, this is time, space and theme. 3 axes. We are using the 3 axes. Time, prehistoric to up to 16th century. Okay. Then another one, space. Entire, I already told, entire Tamil Nadu, Kerala and Karnataka, small portion Karnataka and Andhra Pradesh. Theme, political, social, economic, cultural. Of course, prehistoric time there is no political this one only. Afterwards only this one. Okay. So we basically, because we need to display our all the data. One is the period. We need to separate it for the period. Another space. Then theme. We said. Okay. The database of nearly 70,000 and 10,000 images is inside. Okay, next. Here we did the one data structure. Here the feeding is, every touch feeding is there possible. There is a filter also. This is possible. All we did in the antique 1. That some antiquities comes under the antique 1. Antique 2, some antiquities on that for column. Like that we did the one data form. They're feeding all the nearly 10 research fellows worked in the project. Okay, next. Next slide. So here Paleolithic sites only. In this area, I taken Kerala and Tamil Nadu, Paleolithic sites, 231 sites. Next one, Neolithic sites, 89 sites falling in that. Next one, Iron Age sites, nearly Iron Age is more, nearly 2,000 sites is there, Iron Age in this one. Next one. Yeah, here early historic. This is prehistoric. Previous data is prehistoric data, then historic data. Okay, next. Early medieval data. Yeah, next. Medieval only. Next. Vijayanagara period
so
time.
One question for the audience. What is this he is showing? Which stage of database preparation? Which stage he is showing? Which stage of data preparation?
So,
he has shown you, Akshat has shown several stages of data preparation and database making. Which stage he is showing?
few data collected, cleaned. Now is visualization. I am showing the visualization, two type of. One is table format, one is a spatial visualization, just visualization. Next one, analyze. That also I will give the one example. Analyze also. Okay. Next one. Here, all the data, all the historic data. Okay. Next. So this is overall our collection, Paleolithic to up to Vijayanagara, 16th century data, whole data sets in this slide. So this is two claims, this is not possible. So if you're using the web mapping, because this type of all data is not possible to put it in the hard copy format. If you internet format, it is easy. This technology is easy to zoom in. If you looking in the Google Earth map, if you zoom up to your location, zooming is possible. That's why this technology is very helpful for the huge database collection is one. Next. So I just, for the presentation purpose, I taken the Chola Mandala only for the presentation purpose. Because data is there, I want to show it to you how is one. So I taken the Chola Mandala only. Yeah. Okay. Next. So here, political, we did the Mandalam, different Mandalam and Valanadu, chief territories, royal center, all the things we did it on. Then cultural, architecture, inscription, art and cultures, we taken this one. Then social, religious center, habitation, settlement site. Because sir already in this institute, because settlements, not only royal center, if you surrounding all the settlements is giving the idea that's the purpose. Then economic, poetry, water sources and commercial we taken for the economic one. Okay, next. So where is the database? We collected our own field work, same time from different sources. Our AISI published volumes, epigraphic data volumes, all the things one. Then state archaeology, published by the MPhil thesis, PhD thesis, because this is involved in Tamil University, Kottayam University, then Mangalore University, Hyderabad Central University involved. Their PhD thesis all are we taken for this work. Then field work also. We did the new findings also, exploration sites we did. Okay. Then the secondary data from already published book all we taken. Then the Periyapuranam, Devaram, all other literature also, old literature also we taken. The database. Next. Then base map, there is already digital map is available for the drainage data, road network, all available, nowadays is available. So that database we used backside. The software we used ArcGIS, QGIS and Google Earth also we used. But that's location mapping, all the things we used. Okay, next. So just one, how we mapping the one mandala based on the this one epigraphy, literature event. If you read the English one, because in the Tamil they mention the north, what is the boundary, one river. North is the Vellaru, south also is the Vellaru. Then another side is one place. Kottakarai one place. Then another side is ocean, sea is the next one. So like that we mapped for the, because not like a state map. If we now we have the precious map for the state or district or the map is there, but this is based on the interpretation only. So Vellaru, so north Vellaru, south Vellaru, then one side is a Kottakarai, for the west side Kottakarai we taken near, then one side is sea. So based on that we mapped it like that. This is the Cholamandalam boundary mapping. The next. Like that, yeah. Then with the finding places based on the epigraphy, they mention the places is there. So using the topo sheet, there are small hamlets also we have. So using that, and the red color one from the epigraphic one, the new one is topo sheet name is new one, modern names. That one is old name, historical name. So we interpreted all the help of the historian only. They did all this work. So next one, I just give the examples how they mapped all the things. Okay, next. Yeah, next. This is all our same example. Then next table. Then the village modern data. Which Nadu, which small territory they mention. Location, old location, epigraphy evidence location, then modern name in the table, then that particular place comes under the which Nadu, with Kutram, this is there. That also we mapped latitude, longitude for the geospatial spatial mapping purpose. Next one. So here I just only historical places I mapped. Next one, that particular Nadu we mapped here, Nadu Kutram. Next one, based on that one, we created the small unit boundaries. So if this is up to now if you find a new inscription, if it comes on the next to the boundary, then boundary maybe it will change. Because if Kundram, if you know another inscription is found, they will come here, then the boundaries will change like that. At present, based on the database, we mapped like that here. Inference, yeah. So the next is interpreting based on our data. We know the places, we know the Nadu Kutram and the epigraphy based on the database. So based on that one, we are creating the maps. Okay, yeah. Next one. So like that, we mapped Valanadu, Chief Territories, Nadu and Thaniyur, Royal Center, all these things we mapped. Next. Yeah, this is the overall picture. Next one. Valanadu map. Next one. Because I given the example, based on that we are doing all the things. Okay. Chief Territories, next one. Nadu and Thaniyurs. Okay. Next one. Then Royal Center, Chief Others is one. Next. Okay, up to now political. It's a political one. Now I am coming under the cultural. Here is architecture. Shiva Vishnu temple, brick structure temple, but in this area. Okay. Next one. So here, if you touch in the internet, if you go, each places we have the photos also. Wherever possible, we given the photos also. If it's the Tanjavur temple, if you touch Tanjavur Pragadishwara photo will come. Different photos also. Nearly 10,000 photos is there inside from Stone Age Stone Age from the Stone Age. Because some factory site, Kaplavadi, we put it in the factory sites. Paleolithic sites, we put in the factory site photos also is there. Iron Age photos all is there. So all together nearly 10,000 photos up to now, all temple photos is there. Inscription, okay, copper plate and inscription. Next one. Okay, next cultural art and nature. Here Jain sculpture, Buddhist sculpture, other sculpture, painting, memorial stones. Because here also we face a lot of problem. Because the antiquity list is too much is coming. All is possible to one. Then we regroup it. Because otherwise it's very one. We regroup all the things in this one category. All this one we regroup it in this one. Okay, next. Okay, this is social religious center, Jain center, Buddhist center, Jain Buddhist centers. This is a part we consider social. Okay, next. This is the same if you take the Iron Age burial type. We use the burial type for the social this one. And then social habitation settlements, different Ur, Brahmadeya, Devanagara, like that, all military settlements we used for the social and the settlements type in this one. Next. Then economic, here Chinese were pottery, coins we used. Next. Economic water resources also we taking care of the dams, reservoirs and sluices, all the data we used here. This is all Kaveri Delta area. Next one. Then economic commercial, then all the Chinese coin, multi-nagaram, oil mill, trade route also be mapped here, some trade routes to this one. Okay, next. Port also coming that one only. So this is our database first. Then I'll just one gap analysis. Here in the Tamil Nadu up to now excavated site. Okay, next. So prehistoric explorer sites up nearly 2075. This is up to that project is now we are updating. So I am showing that only. Next one. Up to now prehistoric excavated sites. So in the all the black dots up to now the prehistoric excavated site in Tamil Nadu only 20 only. So this is why I am telling this analysis. We are now have all the data. We are doing one analysis, gap analysis. Where the gap in the explorer sites and excavated site, where the gap. So for that I am doing this one. Okay, previously I showed all the explorer site. Now the excavated site I showed. You can just next slide. Our explorer and excavated sites, there is a gap is there. All the Paleolithic site is there. That's why I asked, is a cultural gap or our spatial, our working gap? And Akhilesh, yeah, that's why Akhilesh started.
That's what he is asking.
Yeah.
Anybody?
He's the Akhilesh the
No, no.
that
He is the resource person. He is the where.
he,
Yeah.
Shall I say something? Okay, so if you look at here, that's the northern Tamil Nadu where in fact we are working in that area where you can see the concentration. That's the area where we are working. And we have been able to generate quite a lot of data in that. I think a lot of our data also should have been incorporated. I think they have incorporated quite a lot of data. And if you go down, that's the theory area you are seeing. But you will see very little bit in the middle region. So in that region there is a gap actually. So now we have started again working in this area, and hopefully in couple of years we will be able to do that. And if you look at also the very interesting pattern what comes here is your lower Paleolithic and middle Paleolithic, mostly it's concentrated on the northern Tamil Nadu. That is again is the result of the raw material availability, because you have this Satyavedu Alikuli formation in that region which supplies the raw material. But when you come down, you have mostly like late Paleolithic, microlithic assemblages, and in the middle reaches still that requires lot more work. It is very visually clear here. So there is a lot of scope which people can take up in this middle reaches. We are mostly focusing on the northern Tamil Nadu as well as on the southern Tamil Nadu as of today. But we have planned to do the middle reaches as well, because that area is very potential, because Professor Rajan sir has worked in that area, Tanjavur, Trichy area, and they have also reported some of the lower Paleolithic, middle Paleolithic sites on chart and other very interesting raw materials. So that area can also yield quite a lot of good archaeology in terms of Paleolithic.
Thank you. Yeah, that's there. Because of course we didn't update. Now we are updating because of that new project. We are updating all these sites. It's okay. Once we same analysis we will do. But even though the excavated site still in the gaps is there. Same time, yeah, we have the database. Then we are all the which institution working this. That is also we are displayed. Okay, next one. Yeah, this is the same by Iron Age sites. This is Iron Age sites nearly only in the Tamil Nadu, 1667. Then next one, here we go. Excavated sites in the 60. Next. This is almost spreaded. Iron Age is all spreaded in Tamil Nadu, entire Tamil Nadu. Excavation also is done in the entire Tamil Nadu is there. Small pockets, only some, it's not, gap is there. Okay, this is the institution wise we did. Next one. Then the early historic to up to 16th century data. Next. So early historic to historic, nearly we did the 96 sites we did excavated sites. Maybe this early historic maybe is fall old also, because same site is falling the Paleolithic or something is possible. It's from that. Okay, next. So explorer early historic and historic sites, and the excavation what we did this final one. Okay, where's the gap also. This is for the just analyze. Next one. Then if a database ready, I wanted to how the Chennai is from the world, Chennai surrounding. I taken the 60-meter buffer zone. Second, yeah, just next slide. Yeah, Chennai city around from the Stone Age to Paleolithic stage to how the sites are falling. Okay, next. Yeah, this is Iron Age sites. Next. I overlaid all this one. Next one. Next early historic, then early medieval period, then last. Next one. Yeah, medieval period. Next one. So yeah, previous slide. You can go previously. So now we put it. This is useful for the tourist one, because it's all the explorer site. What is the status now? Because of the urbanization, that is also possible. Most of the sites, because after the many sites are not burial sites, all are not there. Thanks to this one JCPs, JCPs, all are now removing. Okay, the next one. Next. Yeah, that medieval period nods are there. Next. Okay, yeah, next. So up to now we analyze. This is analyzed for this analogy because if any vulnerable sites, because yesterday Professor Sir told us the earthquake sites. If earthquake, if flood prone area, if this one is a tsunami or storm surge is possible. Is the my coastal area, Coromandel coastal area. Here is storm surge is possible because we are receiving of 2 to 3 cyclones every year. Storm surge is possible up to 5 meter possible in our area. 5 meter is possible. If it's the 5 meters will come, what has happened is the Mahavalipuram, the Tarangambadi, too many, that all on the heritage sites. What big square I marked is all the heritage and tourism site is there. So what is the status? Not only for this one, for the, because now we are all climate change, the sea level rise, they are telling is up to 2100, it's possible up to 1 meter to 2 meter is possible shoreline sea level rise. If it's sea level rise, our all coastal monuments are, so now we can think about how to conserve these places, how to, this one. Same, not only in the coastal area, now the Chennai flood, Chennai we have a monument, Chennai flood, Mumbai flood, the many flood is coming, because nowadays because of the road urbanization, all is high, when the roads are high, your monuments are going inside, down, so the water are in the flood going inside. So we need to take measure. That type of analysis also is possible using elevation models are possible. Okay, next. Okay, just I am summarizing here, I am finishing this one. JS are useful data storage and retrieval. Then provide the visual representation of the data. Because if you already saw how is the visual, then communicate easily to public, communicate this, all your findings is easily to communicate. Then this representation can reveal patterns and trends, how the patterns are falling, how the trends are going, because interpretation like that. So, okay, this is the main, and the analyze purpose also we are using. Okay, thanks. Yeah, just next one. Yeah, just bibliograph. Next one. All right. Thank you.